Let's study chapter 17, problem 3. So this is on page 478. Around the year 1920, I remember it well, nobody really thought that the universe was expanding. Everybody thought that the universe was static, that everything pretty much stayed in one place. Then about that year, airplane coming by, we'll just wait a moment. Then about that year, a young astronomer named Edwin Hubble measured the velocities. Of a good number of galaxies in the direction radially away from the Earth. And what he found was that if he plotted the velocity versus the distance of the galaxy from us, that everything went up and to the right. That is, the further away the galaxy was, the higher the velocity it had away from us. So if we look at that in terms of a picture, then these galaxies right here would have a velocity about like that. But these would have a larger velocity, and the ones out here an even larger velocity. And the further away the galaxy was, then the larger the velocity of recession, that is, its velocity in a radial direction away from you, would be. And of course, the straight line graph will have a slope. And the slope of the straight line graph indicates the change in velocity with the change of distance, and that means that the velocity is proportional to the distance, and the constant of proportionality is called the Hubble constant, d. It's the slope of the graph. Now, on the first night that Hubble plotted up his points on a graph, it was late at night, and he was the only person in the building, and he suddenly realized that the universe was expanding. And he knew that he was the only person in the world at that moment that already knew that the universe was expanding. And he was so excited that he wanted to tell someone else. So he rushed out into the hall, but the only other person in the building at that hour was the cleaning lady. So he ran up to her very excitedly and told her, "The universe is expanding, the universe is expanding." And of course she leaned on a mop and she nodded very appreciatively, "Yes, the universe is expanding," and she went back to mopping the floor. And it was only the next day that Hubble could actually announce the results to the world. And it's been a very dramatic result ever since. That because of his work, we know that the universe is expanding, and the constant of proportionality is h, named in his honor, the Hubble constant. So in this problem, we have some given data, and we're asked to use the Hubble law, that V equals hd, to find the remaining. So this is problem number 3, and the page is on page 478. Now h is equal to 70 as long as the units for distance are in megaparsecs and the units for velocity are in kilometers per second. So you have to make sure your units agree, that to use this formula, your distance must be expressed in megaparsecs, and your velocity must be expressed in kilometers per second. So I'll read the problem. A galaxy has a recession velocity. Again, recession means it's receding from you in a straight radial direction. It may have some velocity to the side as well, but that component you cannot measure. You can only measure the component that's receding from you, that's going directly away from you, and you measure it by the Doppler shift. Recession velocity of 19,250. So the velocity is equal to 19,250, and the units are correct. Check. So we can use them as they are. And we want to know its distance in megaparsecs. So since we want the answer in megaparsecs, we can use the formula directly. So to know the distance, we divide both sides by h, and they cancel on the right side, and we get that v over h is equal to the distance that we want, and the velocity is 19 and 250, and the Hubble constant is equal to 70. So this is going to be our distance. And the first thing we notice is that the two zeros cancel, and we divide 7 into 1925, and we get a 2 and a 7 and a 5. 275 megaparsecs is the distance and the answer to the problem.